Four completely different things just happened on that screen: recognizing a face, answering a spoken question, diagnosing a crop disease from a photo, catching junk mail before you ever saw it. All four get called AI. So does a chess program from the 1990s. So does whatever's about to power the next thing you're told is revolutionary. Either AI means almost nothing, stretched over anything vaguely clever a computer does, or there's one real idea sitting underneath all four of those clips. There is, and it's simpler than the hype makes it sound. Welcome to the Artificial Intelligence Institute Africa, Ubuntu Guild's videos on AI. My name is Dr. Dennis Magaya, Chairman, Artificial Intelligence Institute Africa. This video covers the first foundational question of our entire course. What is artificial intelligence really? Before we dive into the details, let me show you the road ahead. We are covering 3 layers. Layer 1 is the core definition, what AI actually is, broken into 4 simple parts: perceive, reason, learn, and act. This is the foundation you must lock in. Layer 2 is the historical context, the 3 eras that have shaped how we build AI, from handwritten rules to statistical learning to deep learning. Layer 3 is the classification, how we categorize AI by breadth and by internal approach. Layer 1 is your foundation. Layers 2 and 3 are your map of the territory. Let's start with Layer 1. Here's a definition worth holding on to for the rest of this course. Artificial intelligence is the study and practice of building computer systems capable of perceiving their environment, reasoning over what they perceive, learning from experience, and acting autonomously to achieve a goal. Worth breaking down the 2 words themselves, since the definition leans on both. Artificial simply means built rather than naturally occurring. The intelligence here runs on hardware someone designed, not a brain that evolved. Intelligence means the capacity to perceive, reason, learn, and act toward a goal. Nothing mystical is being claimed by the word intelligence here. It's a functional description, not a claim that the system is conscious or human-like. One more detail worth flagging early: that goal a system acts toward is typically set by whoever designed it, not chosen by the system itself. But here's the hidden ingredient that makes the whole loop work: data and experience. A grandmother's predictions about the coming rains are accurate because she has decades of local experience to draw on. She has watched the clouds, felt the wind, and seen the patterns repeat season after season. An AI's predictions are only as good as the data it has been shown, garbage in, garbage out. The quality, diversity, and origin of the data determine everything the system becomes. We will explore exactly how data shapes intelligence and why training a system on European forests makes it blind to African Ubuntu. Every clip from the cold open fits this definition exactly. A face unlock system perceives a camera image, reasons about whether it matches a stored face, and acts by unlocking or refusing. And if it's a system that improves over time, it's also learning. Said even more simply, AI is any system built to perceive something, think about it, learn from it, and then do something as a result. The exact 4 things you do without thinking all day, every day. But wait, isn't AI just machines that mimic human intelligence? If you've encountered AI before this course, you've probably heard it defined that way. That definition isn't wrong exactly, but it describes AI from the outside, what it looks like from a distance. It doesn't tell you what to actually build. AlphaFold predicts how proteins fold into their 3-dimensional shapes, something no human can do by eye at all. A fraud detection system spots patterns across millions of transactions at once, far beyond what any human analyst could hold in their head simultaneously. Neither of those is mimicking a human. There's no human version of that skill to copy. The perceive, reason, learn, act definition describes AI from the inside instead, not what it resembles but what it's actually built from, a definition that keeps working no matter how far past human capability a given system goes. Even in humans, intelligence isn't one single thing. Psychologists distinguish several kinds: IQ, EQ, musical, and linguistic intelligence. This matters for AI because when people say AI isn't really intelligent, they're often comparing it to just one of these, usually IQ-style reasoning, while a system might be strong in one dimension and have no equivalent at all in another. Intelligence is a functional capacity. Can a system perceive, reason, learn, and act to solve a problem? Consciousness is something else, subjective experience. Is there something it's like to be that system from the inside? A thermostat has neither. A calculator has a sliver of narrow intelligence and, as far as anyone can tell, zero consciousness. Every AI system in this course falls into that same category, functionally intelligent at a task, with no established evidence of subjective experience at all. Throughout the entire natural world, intelligence has always sat on top of consciousness. AI breaks that pattern for the first time. It shows real, functional intelligence without any accompanying consciousness at all. That's not a minor technical footnote. It's the first time in history intelligence and consciousness have ever come apart. Closely related is sentience, the capacity to have feelings, pleasure, pain, distress. A simple animal might be sentient while having very limited intelligence. An AI system might handle a narrow task with impressive competence while having no sentience whatsoever. Say it back in plain words. Intelligence is what a system can figure out and do. Sentience is whether it can feel anything while doing it, and today's AI shows no evidence of the second. Does intelligence require a biological brain? The functional definition says no. Intelligence is defined by what a system does, not what it's made of. Biology is the only substrate evolution has produced intelligence insofar, but nothing ties intelligence specifically to neurons. A system built from silicon that genuinely perceives, reasons, learns, and acts satisfies the same definition a brain does. Many animals show real intelligence. Chimpanzees use tools, crows solve multi-step puzzles, octopuses navigate mazes. What distinguishes human intelligence isn't raw problem-solving in any one narrow task. It's the combination of abstract, symbolic reasoning, complex language, and cumulative culture. The ability to build on what previous generations learned rather than starting from zero. That combination is what let humans build mathematics and civilizations, and eventually the very systems this course is about. Animals demonstrate real, measurable intelligence within their own narrow domains. But human intelligence is distinguished by abstract reasoning and cumulative culture, not simply raw processing power. That same pattern, narrow excellence without general intelligence, is exactly what we'll see again in a few minutes when we get to narrow AI. Think about a grandmother in a rural village reading the signs of the coming rainy season. She perceives the clouds, their shape, their color, and the way the wind has shifted from the east. She reasons, the wind has turned. The clouds are building, just as they did before the heavy rains last season. She has learned these patterns over decades of living closely with the land. Every dry spell taught her something. Every good harvest confirmed a pattern. And then she acts. She calls the children to bring in the drying maize from the open yard and covers the firewood before the rain comes. That loop, perceive, reason, learn, act, is precisely what AI systems are built around. Just running on silicon instead of running on you. A spam filter perceives an incoming email, reasons about whether it looks like junk, has learned from millions of previous emails what junk tends to look like, and acts by sending it to your junk folder instead of your inbox. A farmer's mobile app perceives a photo of a cassava leaf, reasons about the patterns of disease it has learned from thousands of previous images, and acts by telling the farmer whether to treat the crop or pull it out. Same loop, different body, same ancient pattern of reading the world and responding to it, different material. So one more time, in one sentence, an AI system is anything built to perceive, reason, learn, and act. That four-part definition hasn't changed since the 1950s. What's changed is how engineers have actually tried to build systems that fit it, and that history breaks cleanly into three eras. In the 1950s, the dominant approach was symbolic AI. Researchers handwrote explicit rules, if this then that, encoding a human expert's knowledge directly into the machine. MySyn, a 1970s medical diagnosis system, is a classic example. A doctor's actual diagnostic reasoning, typed in by hand, rule by rule. These systems were easy to inspect and explain, but they were brittle. From the 1980s through the 2000s, statistical learning took over. Instead of handwriting rules, engineers built systems that inferred rules from data, grounded in probability theory. This is the era that produced classical machine learning as most people picture it today, a system shown many examples and left to work out the pattern for itself. From the 2010s to now, deep learning has driven the most visible breakthroughs, made possible by three things arriving together at once: enormous labeled datasets, GPU hardware fast enough to train on them, and better techniques for training very large neural networks. Human wrote the rules first, then machines learned simple rules. Now, machines learn complex patterns from massive data. Every AI system can be broken into the same four components. Perception is computer vision or speech recognition. Reasoning is logic systems or search algorithms. Learning is machine learning specifically, improving performance over time. And action is robotics or automated control, turning a decision into something that actually changes the world. AI systems also get classified by a second dimension entirely, how broad their competence actually is. Narrow AI, also called weak AI, means a system built for one specific bounded task. This is every single AI system that exists today, including everything in the cold open. Artificial General Intelligence, or AGI, refers to a theoretical system with broad human-level adaptability. No such system currently exists. Super AI refers to a hypothetical intelligence exceeding all of humanity's combined cognitive ability. This remains speculative. Say it back in plain words. Everything real today is narrow AI, genuinely good at one job and nothing more. AGI and Super AI are ideas people discuss, debate, and plan around, not things that currently exist. Separate again from how broad a system is, there's a third question. What internal approach does it actually use to reason? Knowledge-based AI uses explicit human-defined rules and logic. A simple chatbot that follows a script is knowledge-based. The rules are fixed. The system never learns. Statistical AI uses probabilistic models learned from data, the backbone of classical machine learning. Neural and hybrid AI combines deep learning's pattern recognition strength with symbolic reasoning's interpretability, an active area of research trying to capture the best of both approaches at once. Think back to our examples. A rule-based chatbot is knowledge-based. A rainfall prediction system is statistical. And the cassava disease app is neural AI, using deep learning to spot complex patterns no human could write down as a rule. Every category and paradigm covered in this video shows up together in real deployed systems: chatbots, fraud analytics, recommendation systems, and factory quality control. Increasingly, right here in Africa, AI is showing up in farmers' pockets, diagnosing crop diseases and predicting weather patterns with the data they already have. Let's bring it all home. Layer 1. AI is any system built to perceive, reason, learn, and act. None of this works without data and experience, the fuel of the entire loop. Layer 2. We've built AI through three eras: symbolic, statistical, and deep learning. Layer 3. Everything today is narrow AI, built using knowledge-based, statistical, or neural approaches. Understanding what AI is, this four-part loop. is the first step toward making sure it works for us, not just to us. AI is not a neutral mirror, it reflects whatever data it is trained on. If we do not build AI on African data, African problems, and African experiences, the systems of the future will not see us. Thank you for watching this Artificial Intelligence Institute Africa video, brought to you by Ubuntu Guild. Subscribe to our AIIA YouTube channel and to Cognify.